There is something unusual about driving through a major city. You can be surrounded by buildings, business establishments, intersections, and pedestrians. And yet, somehow, there is another road directly above you. Not a bridge crossing a river, not a temporary structure, a full-scale road carrying traffic right through the city. But why? When a city needs more room for traffic, the obvious solution would seem to be simple. Build a wider road, add another lane, make more space for cars. Except there is a problem. In a dense city, there often is not any more space to give. And that's when roads start moving in directions they normally would not. Up. And sometimes down. As cities grow, their roads have to serve more and more people. Commuters need to get across the city. Buses need to move through neighborhoods. Deliveries have to reach businesses. Emergency vehicles need reliable routes. And millions of individual trips have to share the same limited network. Out in the countryside, adding a road is relatively straightforward. There might be a farmland, forest, or undeveloped land besides the existing route. But cities are different. The land next to the road may already be occupied by buildings, or sidewalks, or businesses, or another road. So widening a street is not simply a matter of pouring more asphalt. It can mean demolishing buildings, moving utilities, acquiring private property, and fundamentally changing an entire neighborhood. The more valuable the land becomes, the harder the decision gets. So what if you did not build outward? What if you build upward instead? That is one of the fundamental ideas behind elevated urban roads. Instead of asking the city to surrender another strip of land, engineers can put another layer of traffic above the existing streets. Now, two things can happen in roughly the same physical location. At ground level, local traffic can continue using the streets. Above it, vehicles traveling farther can pass through without stopping at every intersection. The road has not eliminated the traffic, it has separated. And that distinction is important, because one of the biggest problems with urban traffic is not simply the number of vehicles. It's the number of things competing for the same space. Cars turning, cars entering, cars leaving, pedestrians crossing, buses stopping, traffic lights changing. Every one of those interactions creates another opportunity for movement to interfere with movement. An elevated road changes that equation. Instead of making every vehicle interact with the street below, some traffic can simply pass over it, the street can continue serving the neighborhood, while the elevated road carries traffic farther across the city. This idea is known as grade separation, and it is not limited to elevated roads. Bridges, tunnels, overpass, and underpass all use the same basic principle. Take movements that would otherwise compete for the same space and put them on different levels. That can reduce conflicts between different kinds of traffic and allow each layer to do a different job. But there is an important catch. Separating traffic does not make the road disappear. It just changes where the road exists. And that comes with its own set of trade-offs. But there is a catch. Building a road above the city may save space at ground level. But the road itself still has to occupy space. There are support columns, there are ramps, there are exits, and there's the structure itself, stretching through the city above everything below it. So while an elevated road can separate traffic from the streets, it does not make the road invisible. In fact, from the perspective of someone living or walking underneath it, the road may become impossible to ignore. It can change the amount of sunlight reaching the street. It can create noise. It can alter the view of the surrounding buildings. And it can change the character of an entire neighborhood. There is another problem too. An elevated road can travel above the city, but it still has to go back down. Every entrance and every exit needs a connection between different levels, and those connections take space. So the city may have gained another layer for traffic, but it has not created free space. It has simply rearranged the space it already had. But if building upward only rearranges the city's space, why not go in the opposite direction? Underground roads seems like an obvious solution. Instead of putting traffic above the streets, put it beneath them. The surface can remain available for buildings, sidewalks, businesses, and public spaces. And from above the ground, the road essentially disappears. But underground space is not empty space. Cities already have entire networks beneath their streets. Subway lines, utility pipes, drainage systems, building foundations, and other tunnels. So digging a new road is not like digging through an empty field. Engineers have to find a path through the space that is already being used. And there is another challenge. The deeper and more complicated a tunnel becomes, the more infrastructure it needs to keep people moving safely. Ventilation, lighting, drainage, emergency exit, fire protection. All of these systems add cost and complexity. So going underground can solve one problem while creating another. And that brings us to a bigger realization. Whether a city builds up or builds down, it is still working with the same limited amounts of space. And this is where a city starts to become something more than a flat map. At street level, you have local roads, sidewalks, businesses, and pedestrians. Above them, there may be elevated roads carrying traffic across the city. And below the surface, there can be subways, tunnels, utilities, and other infrastructure. All of these systems are competing for space, just at different levels. In other words, a modern city is not simply built outward. It is built upward and downward at the same time. And the more densely developed a city becomes, the more important those layers become. Because the challenge is not just finding somewhere to put a road. It is making sure that all of these different systems can coexist without getting in each other's way. And that's where things become particularly complicated. Because eventually, every layer has to connect to another one. An elevated road cannot stay above the city forever. Eventually, traffic has to come back down. And that's where ramps become so important. A ramp may look like a simple connection between two roads, but it needs enough distance to change elevation safely. It also needs space for vehicles to merge, to exit, and to adjust their speed. And when several roads meet the same area, those connections can quickly become complicated. One road needs to go up, another needs to go down. Traffic needs to merge, other new traffic needs to leave, and somehow all of it has to happen without the different movements interfering with each other. This is why urban interchanges can occupy so much space. The elevated road may save land by moving traffic above the city, but the connections between different levels still have to exist somewhere. And in a dense city, that space is really free. So even when engineers find a way to stack roads on top of one another, they still have to answer the same question. Where do all those connections go? And this brings us back to the original question. When a city runs out of room, the answer is not always to build another road, because every piece of space has a cost. The same land used for a highway could be used for a sidewalk, a railway, a park, or simply more room for people. So urban transportation is not just an engineering problem, it's also a question of priorities. How much space should a city dedicate to moving vehicles? And how much should be reserved for everything else? There isn't one answer that works for every city, but every city faces the same basic constraint. There is only so much space to go around, and every road, whether it's above the ground, below it, or right at the street level, has to compete for that space. So, How do cities find space for traffic when there isn't enough room on the ground? They build upward, they build downward, they separate different kind of movement, and they connect those layers with roads, ramps, bridges, and tunnels. But none of those solutions create more space. They simply arrange the space a city already has. And every solution comes with a trade-off, because in a city, space is never truly empty. It's always being used for something. So the next time you see a road above a city, look at everything around it. That road is much more than a way to get from one place to another. It's a solution to a much bigger problem. How to make a crowded city keep moving. Until next time, drive safe, and I'll see you on the road.